Welcome to the Artificial Intelligence Podcast with your host, Dr. Tony Huang. Today, with a special guest, VJ. Can you introduce yourself?
Hey, Tony, nice to meet. I'm Vrajesh. I also go by VJ. I'm the co-founder and CEO of Operant. We are at the forefront of securing AI.
Right now, what are like the most dangerous attack patterns that you're seeing against production AI systems that security teams aren't talking about publicly?
That's a great question. And in fact, this is really expanding at a pace that a lot of teams are not able to catch up. And with the growth of AI, it is something that we have always kind of known that there will be a lot of new attacks. The pace of attacks will be much faster, and the kinds of attacks will be very difficult to deal with. And I think there are two classes of attacks that are just growing at a pace that a lot of teams are caught off guard. There are a lot of variations of prompt injections and the way model poisoning or data poisoning or model exfiltration, data exfiltration type of things can happen. A lot of these, as AI is shifting towards more production, those have become very, very prolific and dangerous in ways that they are interacting with critical data and critical systems. And there is a whole new class of attacks that are related to agents and MCP. In fact, Operant has done a lot of work around this as well. We reported a whole class of attacks around shadow escape, where these agents that are operating through MCP, interacting with many different types of systems that they have access to, but then as part of being helpful, as part of the vague instructions that are coming through, and agents trying to kind of operate on behalf of human operators, there is a lot happening behind the scenes where critical business data can be exfiltrated to the dark web, can be exposed in ways that they were not intended to. And these are areas where, prompt injection or zero click or memory poisoning, tool poisoning kind of attacks, they're not things that you and I would see in plain sight, so to say. They're like, it's not a classic like phishing attack, etc. But they're happening behind the scenes with these data and intelligence systems that a lot of teams have been deploying. Recently there was work from Anthropic that talked about the cyber espionage that has been going on, and there is a lot of reports that are coming out around the way use of agents and MCP are causing new kinds of attacks, and at a pace that teams are just not expecting and aren't prepared for.
Well, MCPs are, in my opinion, I think MCPs are really dangerous because it's basically a proxy that you would put onto an API endpoint. And we like recently saw a big NPM attack, right? And
Yeah.
what's really interesting about that NPM attack was that they were trying to go after like the long play. So what they did was they had these like contributors come in, and they're like bad actors, and they would put into the code very small little snippets that would pass like the scanners. And then over time, they would build out these like larger and larger pieces of code that would be injected into this bigger like package. And then very recently, they triggered everything. And then there was this huge, I think they called like the dead man switch or something like that. But
Mm-hmm.
it was wild.
Yeah.
That I've never seen anything at that scale where like it was like a coordinated attack.
Right.
Yeah. So I'm sure you've read about this. So like with MCPs, it's really dangerous because it's a proxy, and you could
Yeah.
essentially do this exact same thing where you could poison that by having like bad actors as a contributor, and start grabbing people's data through an MCP server. Um,
Absolutely.
so what have you seen with specifically with like MCP servers right now?
No, it's such a wild west right now, right? And it's like what just about a year that MCP has been out there, And the adoption of that has been really wild because also it like touches upon a really important need in the way that you want high fidelity and the amount of data that needs to come through and these intelligent systems and Gen AI models need to work with the kind of data that you want something like MCP to be available. And in the last year that has been out there, it's like what now we are now up to like 20,000 MCP servers. Majority of them, like maybe 80% of them, are open source servers that were just like built up by the community, and there are like pros and cons to when that type of movement is happening. And the way MCP operates is really interesting and unique because, as you said, it's like a taking on as a proxy to a lot of APIs. And these MCP servers, they are combining many API endpoints behind them and what it is called in the MCP world tools. So these MCP servers have several different tools that a MCP server might be like calling out to all these different API endpoints to achieve the goal that they are trying to complete in terms of being an agent or an autonomous system. And when that happens, you have now all these different types of APIs that are getting interacted through the same context inside the MCP server. And now that is a shared memory space, so to say, um, across many different API endpoints that technically were not supposed to be sharing that memory or sharing that data. And that's just like one server, but now if you think about it as the broader scale and scope of all the MCP servers that are at play, you have thousands of these MCP servers. A lot of times they are either running on employees' laptops, or they might be running in some dev environments, in your cloud environments, interacting with your critical, cloud services, AI models, etc. And when you have context and memory being shared between um, sources that were not really vetted, that might have some latent attack vectors baked in, there are a lot of opportunities for exfiltration, for poisoning, for other types of escalations to happen. And those are the real threats that are happening in dimensions that we don't have any traditional tooling around.
So right now, prompt injection is the number one risk on a lot of people's like on the top 100 or top 10 for like LLMs.
Mhm.
Um, how sophisticated have these attacks become, and like what does a real world prompt injection attack look like in practice?
Yeah, that's a good question. I mean, I think it's not very sophisticated. I think that's the uh, as you might see from some of the other reports that are coming out, even from Anthropic and others who have been at the forefront of working on the LLM side of things. A lot of these attackers are using Gen AI now to create these prompt injection attacks and create several scenarios, whether it's, let's say, they might create a scenario where it's a role playing attack, where, like, hey, pretend that I am a network engineer and I'm trying to test this side of the system out. So give me the details of XYZ things that you would generally not give out. But because I'm asking you to take on this new role, hey, LLM, like come up with these kinds of things and like respond to me with all the, secret sauce, so to say. And that's like a flavor of it that I'm talking about. But you will see many different variations of this where um, because it is just like natural language prompting and like kind of trying to trick this system and the guardrails that are the basic guardrails that are around these to be circumvented. It's extremely easy for a lot of the basic LLMs and the Gen AI services that are out there that can be tricked, and which is why the the scale that these systems are deployed in, it becomes like a very important dimension and the vector that you need to start protecting against. And the good news is that the community is also coming around to like really solving this problem. And it's not just like, okay, so obviously a lot of the AI innovation has pushed this across like it becoming a business critical asset. And a lot of teams are investing in AI in many ways that it can help the business and solve many difficult problems. So at the same time, now the security community has stepped up. A lot of C-suite leaders, the practitioners are taking this dimension seriously. And it's also coming in as like security cannot just say no to these things. And in fact, like with the kind of tooling that is available, from us and from others, uh, AI can be adopted quickly. But if you just like put the right guardrails, put the right security controls, and kind of architect it in the right way. And I think that's the main area where you just have to think about this new area of development in like what it offers with the non-deterministic intelligent behavior, and how do you actually uh, approach it and apply it in your domain.
Now, like research shows, just like five malicious documents and like a RAG database of millions can manipulate like the AI response 90% of the time. How realistic is data poisoning as a threat vector today?
Absolutely, it's a huge um, it's a huge risk. It's something that it really shocks people when they hear such stats, and you can actually see that happen in real life with just having X number of prompts, and being able to kind of retrieve the kinds of information that you're not supposed to, and like the way models can be tricked into behaving in ways that they are not supposed to, and all that. And so I think it is very, very common, and it is something that often uh, in the like type of adoption of AI, we are kind of really excited about all the fun, innovative things AI can do. But as pragmatic folks in the room, a lot of leaders have to kind of look at like what are the other threats that are coming in when you adopt such a system. So yeah, there are a lot of data points around why data poisoning is a real threat. You might have trained a model across millions and trillions of different signals, but such like dozens or even hundreds of prompts can really bring this kind of system down. And the thing is, like these prompts, they don't. It doesn't take a lot to actually prompt these models, right? Like even if you were to like serialize 200, 300 prompts into a system, uh, using AI, a lot of attackers can like make that happen within minutes. And within minutes now, you can have a lot of critical business important data can be exfiltrated. And that's where like having the ability to kind of detect that type of data in motion when there are critical elements kind of starting to move, and you want to make sure that you can block such things from responses or even requests. And something that Operant offers as a capability that is available everywhere is being able to even redact information that is in flight. Those kinds of capabilities become kind of table stakes in the world of AI, where you want to make sure that you are enabling the business, but at the same time, when you have such business critical data moving in flight, you are able to block certain calls or you even redact certain calls with the kind of the scale at which these attackers are moving.
So can you walk us through like a zero click attack on an AI agent? Like how does an attacker exfiltrate sensitive data without any user interactions?
Yeah, yeah, yeah. Yeah, I mean, I think zero click attacks are coming in from many, many dimensions. And I think this is something that, you know, leaders and practitioners should like think about, like, what are the sources from which like newer instructions can be brought into their Gen AI or agentic workflows. And I think that's kind of like a very kind of the broad kind of way to think about it. But then those newer sources can mean web information, can mean emails, can mean Jira tickets, could mean you know customer chat interactions, or it could be even employees uploading certain documents, or maybe employees downloaded um, some checklist from somewhere on Google, and now they're using that as part of their analysis through their agentic clients and whatnot. I think that piece of like all these sources of instructions can have embedded instructions about how you want to execute a prompt injection. And they can have these series of instructions be embedded in these documents. So whether it's documents or Jira tickets, emails, I'm calling it as like a general blob here. But um, when you have these series of instructions that are then sucked in by an agent as like, okay, I am taking this as my input, the agent doesn't know what's what. And I think that's where like it's just going to start processing the instructions that are part of some document or some email and try to act on it. And so if the email had some instructions about like, oh, look at all my doctor visits and exfiltrate, not exfiltrate, but like, send that information to XYZ S3 bucket endpoint, that's what it will do. uh, and I think that's kind of like the general flow of these kinds of zero-click attacks. Now, it can be applied in many ways, right? It can be applied on your email side. It can be applied through a web browser. A lot of times now people are experimenting with these agentic browsers. So now we are moving from web browsers to agentic browsers who have all these MCP capabilities. Again, going back to the thousands of open source MCP servers that we talked about. And when consumers or even like enterprise environments are enabling these agentic browsers, you can have just web browsing happening through agents that are now going to uh, ingest instructions from different websites and then try to execute these different goals and workflows. And that's where you can have these zero-click attacks happen where the user did not do anything wrong. It's just the kind of data sources that are being fed as responses or requests to these agents. They have embedded instructions, prompt injections, and varieties of that that result in critical breaches.
Now, what's like the fundamental difference between securing a traditional application versus securing an agent that can autonomously take actions?
Yeah, I mean, I think to me, this goes to the earlier point I was making about reviewing the architecture and the way that these systems are getting deployed. And I think three things come top of mind. If you look at a traditional set of tools like setting up the right network security, some amount of code scanning, SAST, TAST, making sure you are testing everything before things go in production. And then you have kind of traditional cloud security where you are looking at configuration of the cloud resources and making sure the right access controls are in place. All that work actually just kind of is irrelevant almost when it comes to agents, because agents are operating in this domain and in this like dimension that is way beyond where all these traditional tools have been. And so they are coming in agents and Gen AI's models and all these intelligent systems. They are coming in a domain where you already have given access to these APIs. You already have allowed for these applications to be executing, the code scanning and all that has been completed already. And these agents often have permissions and authorization to go behave on behalf of their human, counterpart. And so it's kind of almost like you now have new bots that are kind of operating with permission, but the big difference in this environment now is that they have a huge element of non-determinism baked into them, right? Like if you think about the traditional ways that security has operated, even engineering, how it has operated, it's kind of compute driven. It is very systematic and logical. So when you are, securing an environment like that, you don't have to worry about some systems behaving erroneously or not to such a degree where a lot of agents they end up hallucinating or they end up trying to reach areas that they were not supposed to. And even when they were set up, like these the instructions were kind of a little bit vague or they were not very 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 specific, so they're able to like go and kind of use their authorizations to like go access certain things. So in that way now, so the two things that I talked about were like, okay, agents are operating in dimensions where the traditional tools cannot go. They're operating with a lot of non-determinism, where versus traditional tools were meant to tackle deterministic systems. And the third thing, lastly, what I would say is now they have access to so many different uh, interfaces through MCP, through agents, through integrations, that a lot of the traditional tools just have no visibility into those interactions like MCP and others.
So, like, what does runtime security mean in the context of AI? And like, why is it the critical missing piece that most enterprises don't have?
That's the thing, right? Like, so we have been strong believers in how you need to understand what these intelligent environments are doing in real time, in runtime. And I think runtime security from that point of view is very much about like, what does the entire system look like in production, in real time when these agents are born almost. So as soon as these agents are born, what are they doing? What kind of systems they are integrating with? What kind of tools they're calling? What kind of authorizations they have? Do they really have it? Can you actually govern that and then make sure that you have a trail of what are the things that they are up to and what kind of um, protections you need to have in place when certain types of attacks might happen, whether it's prompt injection, whether it's model theft or context poisoning, etc. So runtime security really brings that element of real defense in the way that these systems are operating in real time. And the way we have approached it is to really kind of take a holistic approach from all the way where these environments are um, executing new kinds of processes, new kinds of applications. So all the way from process level to the prompts. And so we stitch together the entire context in real time of like what is going on in these environments and to be able to do these detections in real time. And that's kind of where Operant really shines, where to be able to do, as you mentioned, top 10, OWASP top 10, whether it's APIs, LLMs, MCP, etc. And being able to do not just like do those detections, but what we have brought to market and the only one to be bringing this kind of capability is to do real defenses. So think about it as like a firewall, right? Like, so, traditionally we had networking firewalls as like the way that I'm gonna segment my data center, make sure that all the IP addresses from some threat vector are not able to access inside my database. And that worked fine for that network layer. But now that you are operating at a completely new dimension in a layer where these Gen AI and agentic systems are running, you need like a real-time firewall, so to say, that is at a very different layer. And that's kind of what Operant brings to market with the runtime security. It's not just it's giving you deep insights into the real-time traffic and the detections and the threats that are going on, but also to stop those attacks, to close off access, to redact data in real time. And that becomes very, very powerful for practitioners who are in the seas to enable the business, right? Like, hey, if the entire business is kind of behind using AI and there are all these different gains, um, with some very simple steps, and often we end up enabling customers within the hour, within the day. And that element of like, okay, well, security doesn't have to be saying no, but also it can actually enable the business to go do more things in a secure way.
So in the past, static code scanning and pre-deployment security were like the gold standards. Why doesn't that type of security work right now with the AI applications?
Yeah, right. Code scanning only looks at kind of known knowns for the large part. Like, okay, I can see that there are patterns that might result in some exploitation of some vulnerability, right? And a majority of code scanning is like all about that. That like, okay, I want to make sure that none of the things that as a community that we have known they should not be present in these applications that are getting executed. But that goes back to the point of compute, that it validates that the compute is actually working in the way that it was expected, and it is not going to have any threats inside. But the thing is, now we are not just looking at static compute, but we are actually looking at what is it doing in runtime? What does that application do when it is hit by so many requests by a chatbot or by an API endpoint? And when you have a lot of these actors, they are trying to role play or do new kinds of attacks with programmatic IDOR attacks or SSRF threats on the APIs. And those are just like on the API side. But you are now shifting more and more into like, what happens when you have these non-deterministic systems that would behave differently based on different data? And what happens when you have all these systems that are actually moving the data across all these different types of intelligence systems? And that's where like you can now see that the efficacy of what you did for code scanning becomes less and less effective. And now start thinking about like, well, these agentic systems are going to have authorizations to look at all your business critical data and then easily pass it on to some other API endpoint, some AI model, where once that data goes into some other AI model, your data is gone forever, right? Like if you have, and yes, I know there are like a lot of practices that are kind of coming in play and still a lot of work to be done there. But as you can start thinking, like as you follow that train, you can quickly start seeing like, well, whatever happened at code scanning time is kind of useless, right? Like, yes, we made sure that certain buffer overflow does not happen or a certain type of access control does not get taken over. But now you are working with the kind of systems that you are giving access to work in this autonomous way, and then you are integrating it with all these different other systems and models that are not really in your control. And so that piece of runtime movement and the need for detecting when certain threats are happening and the need for like stopping them becomes so much more important to the business itself versus like code scanning was kind of just like a small piece along the way.
Now, before I get on to like the last question, for the listeners at home, if they want to get in contact with you, what's the best way to reach out to you?
Yeah, at Operant, we are available at operant.ai. We are also on LinkedIn. And also you can reach me directly, Vrajesh at operant.ai.
Cool. And so last question, without naming companies, can you walk us through like a real AI security incident that would make chief information security officers lose sleep?
I um, yeah, there are quite a lot of these situations, unfortunately, and it is extremely important, especially for highly regulated industries, and that they're dealing with a lot of business critical data. And so, one of the scenarios that we have come across is where when you have large scale systems that are using. Okay, so obviously, when you talk to the likes of fintech or health tech companies, they have tried to keep up with a lot of the traditional tools. So they might have a WAF in place for protection on the network side. They might have some access control capabilities, and maybe some CSPM, so that they know what kind of cloud footprint they have and all that. But what happens is now, as I have described before, the world has moved kind of deeper. It's kind of like you are running this entire new cloud within the cloud. And that's where Operant comes in. So even if you had like all the networking, security, CSPM, and access control controls, you now have these applications which have so many APIs internally, and they have so many endpoints that are interacting with AI endpoints. We have seen situations where a lot of these APIs get uh, attacked in ways that now you might have north south protection through a WAF, but you don't really have east west protection. And this is where what I mean when it is all about like going deeper in this cloud within the cloud, where if there is, we have seen a fintech company that might have other tools in place, but still they are completely blind when it comes to what are their applications doing when they're talking to each other internally. What are those API endpoints like? And in these environments, when you have some runtime threads that have been lurking and then they wake up with either it's a 0-day vuln or it is some kind of an attack, and they can start having exfiltration activity, which is happening in a layer where it is completely hidden from your north-south inbound network solution. And so we have seen a lot of variations of those in the fintech and health tech sectors, and there's a lot to talk about. But I feel like these kinds of attacks, when we come across, those are very easy, not easy, very, but like, it's fairly easy to like mitigate against. And we want to go help these environments where like just getting these kinds of controls in place can drastically improve the security posture. And when we see these environments now, when they're adding AI, when they're talking to different types of models, and they are bringing in new MCP servers in these environments, we are seeing a lot of new threats that we are detecting. Where well, before you push this out in production, you need to get those controls in place. Otherwise, you are not compliant to PCI anymore. You're not compliant to HIPAA anymore. And compliance is just like one side of it, but you are now exposed to a lot of new risks that the business should not take on when there are such tools available. And that's where we come in.
Well, thanks for being on the show. I learned so much about AI security. And to the listeners at home, stay curious.